Now we go to vectors and matrices. I like to say matrices and vectors. That sounds better. Now it tells us the transformation M, which is 0p q0, maps R onto R prime. So first thing I want to do is look at the coordinates of R. Are they down here? So R of coordinate 2. This is coordinate 2, -5. And it maps it onto R prime right here. So, and R prime is, this is 5, 2. All right, nice. So this is what we'll do. That is what we have right there. Cool. So let's see what it says now. What it's gonna ask us. Determine the values of P and Q. So to determine the value of P and Q, that means when you multiply, let's call the transformation T, or we call it transformation M. So the transformation M multiplied by R results in the coordinate R prime. All right. So we have this matrix right here. Transformation M is 0, P, Q, 0. And when you multiply it by the coordinates of R, the coordinates of R is 2 minus 5, 2 minus 5. So you have to put it in vector form. It's equal to R prime, and R prime has coordinates 5, 2. So put equal 5, 2. So this is going to lead to a simultaneous equation. It leads to a simultaneous equation where we know how the matrix multiplication is row by column. So that means that this end up lead to 0 times 2, which is 0 times 2 plus, that looks like P times -5, and that is equal to 5. So in other words, we're saying minus 5P equal 5, and so P equal -1. That is P. Then from the next one now, the next one, we're going to multiply the second row by this column. So we get 2Q plus 0 times -5, and that is equal to 2. So that means 2Q equal 2, and so Q equal 1. So just to write down the values, because that's what the question wants, you can say P is -1 and Q equal 1. All right, nice. So that's what you have. Now the next thing says describe fully the transformation M. So the transformation M is actually equal to 0pq0, so it's equal to 0p, which is -1, q, which is 1, 0. This right here is a 90 degrees anti-clockwise rotation. How do I know that? Always remember the rotation matrix formula. Remember I told you this. R of theta, the rotation matrix formula, is given by the cosine of theta, the sine of theta, minus the sine of theta, and then the cosine of theta again. This is a rotation matrix. And so if you're to look at plugging in theta as 90, if you let theta equal 90 degrees, let theta equal 90 degrees, then what you'd end up get is the rotation of 90, but you wouldn't get -1 here. Let theta equal -90 degrees. Minus is for anti-clockwise. So R of -90 degrees is going to be equal to, now look, I'm going to take out the calculator and show you. All right, so look at this, the cosine of -90, that's 0. We get back with 0, so good so far. The first one we get with 0, right? Put in right here, so now the sine of -90. The sine of -90, you're going to get -1. See it there? You get -1 right here. Then put in minus the sine of 90. That's going to be -1, which is 1. Just to verify it now, see it here. So put a negative in front of the sign right there. You just get 1. And then the cos of 90 minus 90 is 0. So r of negative 90 is 0 minus 1, 1, 0. What that means is the matrix, the transformation M, is a 90 degrees, or actually it is a 90-degree anti-clockwise rotation about the origin. That's all. It's a 90-degree anti-clockwise rotation about the origin. And that's it. Easy. So now reach irregular vectors now. It says PQRS is a parallelogram in which PQ is U and PS is V. And it says M is the midpoint on QS, or M is a point on QS such that QM and MS are in a 1:2 ratio. It says find what is QS. All right, so what I like to use is I like to use a reference point, right? I'm going to use my reference point as P. So to go from Q to S right here, to go from Q to S, we can go from Q to S. As I said, I like to use a reference point. It usually would be OS minus OQ, but I'm using my reference point as P. So it's going to be PS, vector of the last. Using P as my reference point, it is PS minus PQ. PS minus PQ, where P is my reference. All right, so vector PS is given to be, vector PS is V minus vector PQ is U, so that's V minus U. All right, so I'm using P as my reference. Think of P as the origin. It's always vector of the last minus vector of the first. Good. Now, I need vector QM now. Vector QM would be PM minus PQ. That's what I'd get, PM minus PQ. Now, how do I go from P to M now? That's where the issue starts lie now. To go from P to M, right, that would be equal to me going from P to Q and then from Q to M. So this would be equal to going from P to Q. So I'm going to go to P to Q and then plus Q to M. That's now plus QM. Yeah? And then I need to minus my vector PQ. All right, maybe I shouldn't have done it that way because as you can see, it still worked out just to be QM. So that's crazy, all right? So that was crazy, all right? I end up getting back the same place, so that's crazy. But let's continue. Now, we just need QM, right? This right here, we need QM. Now, QM is 1/3. This is ended up being, because see it here, this PQ right here, so cancel out this minus PQ. So I end up getting back the same thing, which is crazy. What QM, bear in mind, is going to be 1/3 of QS. That's QM, 1/3 of QS. So that was crazy for me to do all of that. So 1/3 of QS, and QS is, we already find QS, so it's going to be 1/3 of V minus U. 1/3 of V minus U. That's all. No wonder 1 mark. All right, so I was trying to use origin to solve it and then end up realizing it never made no sense. This is what you do. It's 1/3 of QS, which is 1/3 of V minus U. All right, because this is QM. This is QM. All right, QM is this right here. And then all of this is QS. You can actually cut them up in 3 pieces. So QM is 1/3 of QS. So I already find QS. Nice. Now it says show that MR is 1/3 of U, 1/3 of U plus 2V. That's MR from M to R. Going from M to R, we can go from M to S, then plus S to R. So we can go from M to S, then S to R. Let's write that down. MR, all right, following MR is the same as going from M to S, and then we go from S to R. That's what we can do. Yeah, all we need to do is go from M to S here. So this is the journey. I'm gonna map out the journey on a line to show you how we're gonna go from M to R. So here's the journey. Let me change the color just to use maybe blue, right? We can go from here to here, and then we're gonna go from here to here. That's all we're going to do, all right? But MS is what? MS is 2/3 of QS. So let's write that down. MS is going to be equal to 2/3 of QS. And then SR, to go from S to R, that's just adding U. That's just plus U. SR is just the vector U. But then QS was what? Looking back at it, QS was V minus U. So this is going to be equal to 2/3 of, in bracket, V minus U. All right, now look at this now. What I'm going to do now is I'm adding plus U. Instead of adding plus U, I'm going to write U as 3U over 3. 3U over 3 and 3 is the same thing. Because by doing this, it allows me to can add my fraction then. Because then this becomes 2V minus, that become 2U plus 3U. And this is all being divided by 3. All right, I just form it as one fraction. All right, so finishing it off up here. So now, let me write it up here now. So MR is ending up equal to 2V minus 2U plus 3U. Now minus 2U plus 3U, when I add these two, I end up just get U. So I end up just get U plus 2V, and this is being divided by 3. I can then factor out 1/3. Factoring out 1/3, I get U plus 2V. And that's it. Easy, soft. Now it says that T is the midpoint of PQ. Prove that R, M, and T are collinear. So T is the midpoint of PQ. So PQ is, this is PQ, and then say T is the midpoint. So T, there's somewhere right here. So this is supposed to be T, right? And then them say we need to show that R, is it R, M, and T is collinear? R, M, and T are collinear. Collinear means in a straight line. So we need to show that R, M, and T, this in a straight line, right? So to do so, we need to find vector. Maybe we need to find vector Tm and vector Rm, or we can use Mr, M to R, and T to M, and show that they are, one is a multiple of the next, and they have a common point. All right, so let's do that now. All right, so in words now, let's write it out. If R, M, and T are collinear, that means these 3 points are in a straight line. So to prove that they are in a straight line, we just need to show that one is a multiple of the next. So I already have MR, so let's go TR then. So vector TR, or vector TR, TM, let's go TM. So vector Tm is going to be equal to, going back around here, how would we go from vector T to vector M? To go from vector T to vector M, would go from T to Q, then from Q to M. So we got to go from, so vector Tm would be going from vector T to Q, and then from vector Q to vector M. Yeah, man. But TQ is what? Going from T to Q, going from T to Q. If the whole of this is U, then from TQ is a half U. TQ is a half U since this is the midpoint. This is a half U right here. So to go from T to Q is a half U. So right, half U. Where did this disappear to? All right, so this is now a half U. This is a half U. All right, nice. And then we need vector QM and vector QM right here. So already found vector QM is 1/3 of V minus U. So vector QM, which was 1/3 of V minus U, I'm going to write it as V minus U over 3. That's 1/3 of V minus U. That's vector Tm. So in reality, you know that we'd have to form it as one fraction, put the LCM as 6, 2 into 6, 3 times. This would become 3U plus, then now 3 into 6 goes 2 times, that would become 2V minus 2U. So what we end up getting is this is equal to 3U minus 2U is just U plus 2V over 6. So U plus 2V over 6. That is vector Tm. Now look at this. If I were to cross multiply the 6, remember this is Tm. So Tm, so vector Tm is equal to 1 over 6 times U plus 2V. Yeah? That's what we have for vector Tm. And then now look at vector Mr. So if I cross multiply by the 6, that means a 6 times vector Tm, 6 times vector Tm is equal to U plus 2V. That's what we do now. Now look at vector Mr up here. So looking at vector Mr, if I cross multiply by the 3, then that means that 3 times Mr would be equal to U plus 2V. But look at that. U plus 2V, U plus 2V. So that means a 6Tm, because this and this end up equal. Them two are equal. So that means 6Tm is equal to 3Mr. Blouse and skirt were nice, see? 3Mr. Yeah, man. So 6Tm equals 6Mr. And so therefore they are parallel to each other, because if you divide both of them by 3, that pretty much means that Tm, divide both sides by 3, 2Tm equal to Mr. 2Tm equal to Mr. That's what that works out to be. 2Tm equal Mr. And so they are parallel to each other. Hence, Tm and Mr, the vectors, are parallel to each other, are parallel and have a common point. They have a common point. They have the common point M. Hence, T, M, and R are collinear. That's how you do this question. Nice and easy. So hence T, M, and R are collinear. All right. Nice. Yeah, man. Soft. All right. So I hope we had fun doing this paper. Realize that easy, man. Soft. Easy, easy, easy little paper. Soft.